Everyone, how you doing today? Wazoo here, and in this video, we're going to be going through the magic of GraphQL with Java Spring Boot. Yeah, that's right. I think this is going to be a really interesting topic to dive into. I haven't touched yet on this channel, so this will be the first exposure of GraphQL to all of you, and I hope it's a really informative and a good introduction on what GraphQL is, what you're using it for, and how to use it with Java Spring Boot. All right, let's get into it. So before we get our hands dirty with GraphQL, let's talk a little bit about what it is. It is a query language, GraphQL, graph query language. It was first developed and introduced by Facebook back in 2012 to help them deal with their services and their mobile apps at the time. They found that they were encountering a lot of issues working with their traditional REST API layers when dealing with communication and news and the feeds and everything on a mobile device. And if you think about it, it kind of can make sense for your brain without even really touching GraphQL before. REST is very good at compartmentalizing resources, but some problems are created when you need a bunch of REST queries in order to pull in the necessary data for whatever it is you're trying to display. If you maybe think of a news application, if you maybe think of a news or media site, maybe that's the easiest way to figure out what some of the challenges with working with REST services are. You've got first you're going to have a call for all of the articles that are appearing on this page here. And each of these calls will also possibly involve additional REST calls for things like images, media, video, any kind of sort of media components of the article itself. And then you might also be displaying the author along with the article. So that might require another REST API call to make. And here, for example, we've got categories. We've got time for the article, how long ago it was posted or last updated. We've got maybe country information like this. So these all require additional REST API calls in order to pull in all of this data. So as Facebook was working on their applications at the time for mobile, they realized that they needed to find something else. Another way of leveraging their REST API, but with some kind of different mechanism for just pulling in the data that they needed and nothing more or nothing less. And thus GraphQL was born. So GraphQL attempts to solve the challenges posed by traditional REST interfaces by changing the way you approach your calls for data. It gives you a flexible way to query the specific attributes that you're looking for whatever current page you want to display. GraphQL also helps you combat the issues of overfetching and underfetching, which can happen quite often with the traditional REST approach. And if you think about it, that kind of makes sense. Let's say, for example, that you are displaying this homepage here that we have, and perhaps there's maybe a sidebar of all of the previous authors that have contributed to these articles. For example, let's say the top 10 authors. It may require pulling in all of the data associated with an author just to display their name, when all you need is their name, like maybe their ID and their name, for example. So things like that. That's just one tiny example of overfetching, which you don't really notice on a desktop browser, but on a mobile device where you are moving in and out of coverage, or you're on different quality of networks, or you've got a different kind of, you're faced with different kinds of devices, then all of these things really start to add up as you overlay the amount of calls you need to make for any data for your application. So what we're going to do in this video here is we're going to go through setting up GraphQL with Java Spring Boot. We're going to go through putting together a pretty simple API to demonstrate how to work with GraphQL and how to use it to structure queries for results that you want to pull back. I think this is going to be a really interesting tutorial. I hope you enjoy it, and leave a comment down below, like the video, and let's get started. Okay, so first things first, we're on the traditional start.spring.io website. This is a common gateway for generating your projects for Java Spring Boot. It provides you with a handy dandy zip file that you can just open in your favorite editor, and it will have all of the default dependencies that you've chosen during this wizard. So we're going to be using Maven and Java, and I'm going to be using 3.1.4. And let's just call this Spring Boot 3 GraphQL demo. That's the name I'm going to give it. I'm going to be using a jar file. I'm going to leave it on 17. We're not using anything specific to 21, but we'll keep the default of 17. Okay, for dependencies, I've got the Spring Boot Dev Tools. I've got Lombok. I've got the Docker Compose support. I've got Spring Web. I've got Spring for GraphQL. I've got the Spring Data JPA, and I've got the MySQL driver. So once you have things similarly configured, just go ahead and hit the generate button and extract it to your desktop. Okay, so here we are in IntelliJ, and that's the editor that I'm choosing to use for this. You can open it up in whatever you wish, Visual Studio Code or anything else. And we have a traditional project format that you may have seen already before in several of the projects that we've tackled on this site. The only real addition because of GraphQL is we have under resources, we've got a GraphQL folder. So there's going to be more on that later as we get into this, but just make aware that it's there. Okay, so the first thing is we're going to be setting up Docker, which involves creating a .env environment file. So in the root of your project, go ahead and create a new file, call it .env. And this is just where we're going to create some default usernames and passwords for the services that we're going to define in our Docker configuration. So I've created a few variables here. The MySQL database we're going to be calling is spring_data. A MySQL_user will have a value of spring_user. The MySQL password will have a value of spring_password. And a MySQL_root_password will have a value of spring_root, which will come in handy when we want to log into the database and check things out there. So first, let's go into the compose.yaml file and let's get rid of everything here. And then what we're going to do is we are going to go ahead and create our own Docker file. We're going to be using version 3.8, and we are going to be defining services and networks and volumes. Volumes will be the third one. So under volumes, we're just going to be creating a volume called dbdata. So that one's done there. Under networks, we're going to be creating a spring-network. And then underneath that, we'll be specifying a driver bridge. So then under services, we're going to be creating two of them. One is going to be for our database, and one is going to be for PHP myadmin, just as an easy way to check the database and verify that things are happening the way we're expecting them to. So under database, let's use the MySQL:\latest image. Our restart option will be unless stopped. Our env file will be our .env file that we just generated. And our environment flags will be MySQL_database. Will be that same MySQL_database that we defined in that env file. So that's where Docker will be pulling it from, because we don't want to put any of the secret information in our GitHub repository or source control, whatever it is you're using. So we're using MySQL_password for our password here. And then for our MySQL root password, you guessed it, I'm going to be using $ squiggly bracket MySQL_root_password. And then last but not least, MySQL_user will be $ squiggly MySQL_user and squiggly. Okay, we're going to define some ports, 3306, 3306. That's what we're going to expose. And then for volumes, we are going to define our DB data volume and just give it a folder name underneath that, varlib db. And then networks, we're going to specify the Spring network that we just defined a few minutes ago. All right. So that's it for the database. Now for phpMyAdmin, it will depends on database, the same key name that we just defined above. For an image, we're just going to use phpMyAdmin/phpMyAdmin. Well, the restart option will be unless stopped as well. And ports, we will define as 8081 will be internally routed to port 80 on this image here. Our env file, again, will be the .env file that's in a root, and our environment variables are the PMA_host is going to be the database, and MySQL_root_password is going to be $squiggly MySQL_root_password. And then finally, last but not least, networks is going to be the Spring network that we defined. Okay, so we've got all that set up. If you're quite new to Docker and maybe you've missed my video on how to get it working and up and running with Java Spring Boot, I'll put a link in the video somewhere right about now. And so maybe you can follow up with that later on if you wanted to get further information on using Docker. As always, when working with Docker, just make sure that the Docker desktop app is up and running before you want to use it. Kind of obvious, but I seem to run into that every single time. Okay, finally, let's go in and define some application properties. We are going to define a server port of 8080 just out of habit. We're going to set a logging.level of web to be debug, a logging.level of SQL. We're going to also set that to debug. Use spring.jpa.generate DDL equals true. And that is all we need to get started, my friends. So go ahead and hit the debug button. Just make sure that your server starts and all the containers are starting up and healthy. Okay, so everything looks good. The server started up on port 8080 and everything looks like it's healthy and running. So let's go ahead and stop that. And now let's go into making some models. What I think for this demo, what I want to do is create a author entity, an article entity, which has a relationship back to author. So there's a one-to-n relationship between author and article. And then each article has 1 to n comments on it. So by setting up a basic structure like this, we can demonstrate how GraphQL can come in really handy. In our package root, let's go ahead and create a new package called models and another one for repositories and another one for config. Okay, and let's go ahead and define an author. We're going to be using the entity annotation from Spring Data. We're going to be using the data annotation from Lombok. And then we're going to be using builder, and which means we need the allargs constructor annotation and the noargs constructor annotation. So let's just build a basic author. We are just going to have an ID and a generated value and define this as a long. We are going to have a first name for each author and a last name. And then we're going to have our one-to-many relationship with our articles. So one-to-many mapped by equals author, and cascade equals cascade type all. Okay, we're going to have a list of article, which we haven't defined yet. And we'll call it articles equals new array list. Okay, now for models, let's create the article model. Okay, again, we're going to be using the entity annotation. We're going to be using data. and the builder annotation, and all args constructor, and no args constructor. Okay, and then we're going to define an ID and generated value, pretty much what we just did for author. We'll do the same thing here. Then we'll have a title for each article, and we'll have a content field. We'll then define a many-to-one relationship with a fetch equals fetch type lazy back to author. Each article will have an associated author field. And then we will have a one-to-many relationship with a comment. So cascade equals cascade type all. And we're going to have a list of comments equals new array list. There we go. Okay, and then finally, let's make the comment model. In a real data hierarchy, you're going to have a lot of complex relationships, which will only highlight how useful GraphQL can be, depending on how you use it. Okay, so let's define an entity again, data again, builder again, all args constructor again, and no args constructor. Okay, and again, we'll just have an ID and a generated value for this comment. And the only field we'll have is just message. So whatever the comment was. And then we'll have a many-to-one relationship back to article. So fetch equals fetch type dot lazy and article. Okay. Okay, so everything looks good there. We've got all of the proper package names specified, so everything is resolving, and we have no more nasty red lines. All right, now we'll just set up some basic repositories for each of these models, as we normally do when working with Spring Data. So we'll be needing a article repository, author repository, and a comment repository. Okay, we're going to extend the JPA repository interface and make use of article and long as our keys. Author repository, we're going to set up the same way, and comment repository the exact same way. Okay, so by now, none of this should be really new to you. And if it is, then I do have a lot of other videos that dive into what each of these concepts are that we've just been going through. Okay, so we have a data set. We've got a data model here, a basic data model of article, author, and comment, and a relationship defined between these. And now let's turn to working with GraphQL before we set up any controllers. So in our resources folder, remember there was that GraphQL folder that was created here. So let's create a new file, and we're going to be calling it schema.graphqls. So GraphQL works by having you describe and define a schema, or basically a contract, that interoperates between the front and back end portions of your application. In other words, if you've got this schema defined, then you can give the same schema to your front end developers, and they can run away and go off and create their front end and know what kind of attributes to query from the back end. And likewise, your backend developers can go away and just work from the schema to implement the backend layer for GraphQL. As long as both sides adhere to the schema or adhere to the contract, then you don't really need either side up and running before you test it, which makes it really handy when you're working with different teams that work on different responsibilities of your application. But for now, it is just us working on this. And we have got two we're going to go through two ways of using GraphQL. So the first is a query. So it's going to be called type query with some squiggly brackets. And the second is a mutation. So a query is handy for when we want to pull or extract or read anything from our database. We don't want to modify anything. We don't want to update anything, just read. Then the query is the one that we want to use and define and play with. Whenever we want to modify any data, so if we want to delete anything, if we want to create something or update, then we need to use a mutation, because essentially we are doing exactly what it sounds like. We are mutating the current state of the data that we have already. So let's start with our first, I'm going to comment, we'll come back to mutation. So we're going to start with our query first. So we are first going to get a hold of the articles in our database. So we set up a articles underscore here, and then within square brackets, we're going to be returning a list of articles or array of article. Okay, now right away, the IntelliJ editor, or perhaps in Visual Studio Code, your editor will have the article word keyword here in red or as undefined, squiggly, because we haven't yet defined it. So let's go through and define what an article is. And this is what I mean about a contract. So each article has an ID field, and there's a special type in GraphQL for IDs called ID, capital I, capital D. And this is a required field for articles, so we use the bang attribute or exclamation point. And so each article also has a title, which is a string, which is also required. So we'll use the bang again. It will have content, which is string, and it may or may not be required. And then it will have comments available. So it will have a comment array in square brackets. And these are also optional, so there's no bang at the end of this. Now again, comment is red because we haven't defined it yet. So let's define a comment. Type comment. And again, we have an ID field. And we have a message property, which is a string, and it is also required. If you're a little bit confused as to where I got these values from, we are just doing a one-to-one mapping of the attributes that we've defined in our models. So in our article, for example, we've got an ID field, a title, content, and comments. So we've got ID, title, content, and comments. Okay, so everything should be filled in. This means that we have a query of all the articles in our system. So now what we're going to do is we're going to need a controller in order to work with this schema and GraphQL and our database. So let's go ahead in the root package and create another one called controllers. And let's go ahead and create a article controller. And it will be using the REST controller annotation and the required args constructor annotation. Okay, and it will also be using the request mapping annotation of just /API/articles. And we will be making use of the article repository. So let's do a private final article repository. So normally what we would do in a REST controller is create a mapping for the REST operations, such as get, put, post, or delete. And so we're going to be doing this roughly the same thing with GraphQL. We're going to be using what's called the QueryMapping annotation. And then we are going to be returning a list of articles. And we're going to be returning article repository find all. Now notice the name of our function here, which is lowercase articles. This is very important that this name matches exactly this first property in the query of the schema. This is how GraphQL does all of the magic behind the scenes between your controllers and the schema and the database. So just make sure that those things line up. Okay, now we are going to, in the config folder, we're going to create some seed data just so we have something to query. So let's go ahead and create a new class, and we'll just call it seed data config, which is a convention that I use on this channel here. Okay, to save time, I cut and pasted some seed data that I've set up for this example. I've got all three repositories defined here. And then we override the run method, which, because we're implementing the command line runner, so during startup of our Spring Boot server, if our author repository count is 0, which means if there's no authors in the database, then go ahead and create one using the builder pattern. We'll call it Jack Payne. That will be our first author. It will then save it to the author repository. Then we'll be creating 2 articles using the builder pattern again. The first one will have a title of Article 1 and with the content of this is Article 1, and it'll set the author to our author 1. And similarly, Article 2 will be using the builder pattern again with the title of Article 2 and the content of this is Article 2 using the same author, and then persisting these 2 articles within the article repository. Then finally, we're creating 2 different comments, and we are attaching the one comment to each of the 2 articles, and then finally persisting them to the comment repository. Feel free to go through this on the source code. I did forget to mention at the beginning that it is available on GitHub. The link should be in the description down below, so go ahead and download it as we're going through this, and just to verify the steps that we're taking to set up GraphQL. All right. So we've got the seed data coming in, we've got the database set up, we've got everything configured. There's one more thing we need to implement, and GraphQL will do all this for us, which is really cool. So in our application.properties file, let's go to the bottom here, and we can use a property called spring.graphql.graphEQL enabled equals true. And this is a built-in IDE for working with GraphQL, which is really, really handy. So we don't have to download any external tool. We don't have to go to Postman, nothing like that. It is all within our application, which is really handy. Okay, so go ahead and start up your server. Okay, so if you go to localhost port 8080/GraphIQL, then you'll be presented with this IDE. Now there's a bunch of text in here explaining some of the basics of GraphQL, so just go ahead and erase it if you want or leave it in. It really doesn't matter. And just make sure that you're outside of anything that's commented out, of course. Okay, so how a query works, we've got data in the database, which means we have some articles, authors, and comments now in our data. So what we're going to define first is, well, the only thing we've defined so far is a query. So we're going to define here, we're going to use the query keyword, and we're going to use the open and close squiggly bracket. Now within the query, we are going to be making use of the only query that we've defined so far, which is articles. Okay, now articles, based on our schema, will return an array of article. So what we can do here is specify, okay, so we've got the articles keyword, which is our query, and we only want to remember that we're going to be returning an array of articles. And so for now, let's just pull back the ID value of each of the articles in our database. So let's just type in ID. And notice that the editor will provide this for you just to verify that you've got things sort of set up correctly. So if you hit the run button, then we see that we've got a response of an array of articles and just the ID attributes. So let's go ahead here and let's go with title. We want the ID and title of each article, hit the run button. Now we get ID title. And now let's go ahead and look at comments. And since comments is another collection that we're returning from each article, let's go ahead and within the squiggly brackets, let's define what we want to actually return back from comments. So for now, again, I'm just going to specify ID. So now when we hit the play button, we've got our articles with our ID title, and now we've got the comments array, each returning the ID fields. And now let's specify also the message. We want both ID and message. Okay, very cool. And that's what we've done so far. Oh, look how powerful we have. We've got a ability to have a dynamic and flexible format for the kind of data that we want to present in whatever page is making use of this query. Okay, so let's go back in our server and we're going to add a similar query for author. Okay, so go ahead and hit stop. And back in our schema, again, let's create another query and we will just call this authors. And then we will have in square brackets, we will have a array of author. Now again, since author is not defined, let's go ahead and at the bottom, it could be anywhere, it doesn't need to be in any certain kind of order. We're going to create a type of author. It will have an ID property of capital ID bang. It will have a first name property of string, which is required, last name of string, which is optional, and it will have a arrangement of articles, a collection of articles, which we've already defined. So this resolves itself properly within the ID here, within the schema of the ID here. Okay, so now the same thing. If we have, let's go ahead and create a authors controller just to keep the two separated. We could stick everything into one, but just to be separated a little bit, let's keep the author controller separate from the article controller. Let's make use of the same annotations, except of course we'll be using /API authors, and we'll be using the author repository. And again, our query mapping of authors will have a method called authors, which matches exactly what we defined in the schema authors, and it will return just all of the authors that are in our system. So without needing to do anything else, let's go ahead and restart, refresh the page, and now we've got things sorted out again. So we can, and let's go ahead and do authors. So let's specify authors. And again, since we're returning a list of authors, we want to, for now, let's just return the ID of each author. Okay, so we only have one in the system. And now we want the first name. Okay, Jack. And then remember the last name was Payne. So let's specify the last name field within our authors, Payne. And we can do articles here. Articles. And again, let's see, let's go with ID, title. So just ID and title. So again, we have a similar kind of structure. We've got authors, first name, last name, articles. Now, the really cool thing is that if let's comment out the articles down in here, and let's go back up here and uncomment that we've defined, the articles query that we've defined up here. So if we hit run, now we've got a payload that includes both. Ooh, that's pretty cool. Yeah. So instead of separate calls for each query, what GraphQL enables us to do is to combine all of a similar type of query into one call to the backend. So now we can't combine a query and a mutation within a single call, but we can combine many queries into a single query. Okay, that's pretty cool. I like that. All right, so let's go back to the server and let's look at creating a mutation now. Remember that a mutation is useful for modifying any of the data. So we've got a type query, and now let's define, just because I want to keep it alphabetical, let's call it type mutation above the query, but really it doesn't matter. So we're going to be creating a few different methods here. Let's start with just creating an article. So let's have a method called createArticle, and our parameter we're going to be is a string. We're going to have a content of string, a author ID of ID, exclamation mark because it's required, and this mutation will return a article. So we've got a schema definition for createArticle. Let's go ahead in the article controller and let's put this together. Okay, so we've got a function called createArticle now, and we are going to be working with a title as an input, a content as input, and a author ID. Now, in a normal REST service with Spring Boot, we would be using something like path variable or request body to pull out these parameters. But for GraphQL, we're going to be using something called @argument. So each of these are going to be argument. So you can see that it's not as hard as you think converting your REST services to GraphQL. It really, of course, there's always special cases depending on what you've set up, but for the most part, there's just some different annotations, but the structure is very similar to a traditional REST. Remember, in the query function, we use the annotation QueryMapping. So for mutation function, we need to use the MutationMapping annotation. Okay, so now what we're going to do is we're going to look in the database for the author given the author ID param. And this is just going against the author repository, which we need to now define. So let's pull in the author repository. Okay, so we're going to pull in the author based on the author ID. So we're going to use find by ID. And if we don't, then we're going to be throwing a exception with the argument of author not found. Okay, so now what we're going to do is we're going to be creating a new article. So we'll make use of the article builder pattern. So article builder, our title will be the title that we've passed into the function here. Our content will be the content. Our author will now be the author that we've just pulled out of the database. And we will call the build function. And we'll be returning the article repository.save article. So we're going to persist it. We're going to try and persist it to the database and then return it back to the caller. So let's go ahead and let's start this up. So remember, we've got a default author with the ID of 1. So we're going to use that for our query. So just remember to refresh the page again. And then let's go ahead and get rid of our query. So let's define our mutation here. And we are going to be using createArticle. Okay, and we are going to be specifying a title of new article, content of new content, and a author ID of 1. And we want to return, so we use the, okay, so just to summarize, we're specifying the createArticle mutation that we've just created with a title of new article, content of new content, the author ID of 1, and with the return that we get back from the service call, we want to work with the ID, title, and content fields. And this is what now shows up in our data payload. That's pretty cool. Okay, so we can create an article, and similarly, we can also update and delete article. But first, let's go back into our application here, into the schema. And so what we want to do is create another mutation, and we're going to just call this one addArticle. And we're going to be passing in a article input object. So let's call this article input, which is basically a plain old Java object or POJO with our article properties. So it's required. So let's use the bang and it will return a article. Okay. So now let's go define what a article input looks like. So let's just put it right after type. So type article input, and it will be a, sorry, it's not type. It's going to be an input because it's expecting some input to that GraphQL function. We've got a title property of string, which is required, content field of string, which is not required, and a author ID, which is itself required. Okay, so now let's go into our models folder And let's create a basic object for article input. Okay, so we're going to make use of data and the all args constructor and no args constructor annotations. And then we're going to be using a string title field called content, which is a string, and then a long for the author ID. Now let's go back into the article controller. Okay, and right under this create article, we can now create another controller method for taking in that article input object. So again, we'll be using the mutation mapping annotation, and it will return an article from this function, and we called it addArticle. And we've got an argument annotation, and we want to map the name that we're expecting to be article, which this property of name matches exactly what's in the schema right here, the parameter of type article input. Okay, so it is a article. It is of a type article input. Okay, so now what we're going to do again is we're going to look for the author, which is what we did up here, based on the given author ID. Only we need to change it because we are working with article input. Let's just let it resolve here. Okay, so find it by article input, get author ID. Okay, so once we find the author, we do that. And then similarly, we use the builder pattern on the article to create a new article based on the given inputs from the input object, the article input object. So we're grabbing the title and the content, and we're saving the author. And then we're returning the article repository save. So we're returning the persisted record of this new article. Okay, so let's go ahead and restart the server. Let's go back to our GraphQL, let it restart itself and get ready. Okay, so we've got one create article method here, and let's do a addArticle. And GraphQL is prompting us that it wants a article object, which we are going to define as a title of new article 2. I don't know. Content of article 2 content, and an author ID of 1. Okay, and then for the return, again, let's just list out the ID, the title, and the content fields. And we'll see we've got a new article created with an ID of 102, and we're returning the title as well as the content field. Really cool. I love this a lot. Okay, so we've got a way of inputting an object. Now let's do the same thing for updating an article and deleting an article. Okay, let's go ahead and stop this. All right, so back in our schema, let's just go ahead and add 2 more methods here for updating the article. We're going to add 2 more mutations. One for updating the article. We'll need the ID of the article to update. Article input, and then we'll return the updated article resource or properties, whatever it is we want to query. And then we're going to create a delete article mutation, which will just take in a ID, which is required, and it will return nothing, but let's say it'll return an article. So we've got update article and delete article. So remember, we have to name these methods the same in our article controller. Okay, so let's go back to our article controller. And we've got 2 more mutation mappings. So we've got public article, update article, and we've got an argument of a ID that we're going to use, and then another argument, which is our article input. Article input. Okay. And then we've got another mutation mapping for the deleting. So let's just create it now. Mutation mapping, public void We called it delete article. And we're going to be taking in an argument of the ID. So let's just article repository delete by ID of the given ID. And then for this one up here, we are going to be looking for the article in our repository with the same find by method. And we'll be making use of the ID that we passed into this function, or else we'll throw an exception that the article couldn't be found. So if we find it, let's go ahead and just update the existing article with the new properties. So we're going to set title to the title that we were pulling in, that we're sending in via article input. And we're going to be setting the content to the content that we're sending in the article input object. And then we're going to be returning a updated persisted record of this article object. Okay, so let's go ahead and restart our server again. Let's refresh. Okay, so we're back. So let's just comment out our addArticle. Now, if we want to run a query to see what articles we have in the system, let's do that now. So let's go ahead and run a query of articles, and we'll just call this ID. All we want is the ID. Okay, all we want is the ID. So we've got ID 12, 52, and 102. Okay, so let's comment out the query here, and let's do the delete one first. That's easier to test. Let's do mutation, and then we want to delete the article, and the ID will be, let's delete the 102. And then we don't really want to do anything with the result, but let's make use of the ID field. Okay, and it's null because we're not returning anything from that method, but you can see that we've deleted this article. Or I guess to prove it, let's comment out this mutation, and let's go back to our articles query. And we now no longer see the 102 record here. Hooray! Okay, let's update. Let's now test the update function, or update query, sorry. Update mutation. So again, let's use mutation. And then we want to update article. And let's update article 52. So ID 52. And then we want a article object that we're going to pass in here. Let's use a title of brand new article 52, and content of brand new content 52. And then for our author ID, let's use 1 again because that's the only author we have in the system. And in our resulting object that comes back, assuming this works, we just want to list the ID, title, and content. Let's go ahead and hit the play button. And ta-da! We've now updated article 52 with brand new article 52 and a content of brand new content 52. Okay, so that's all I've got for this demo in this tutorial on using GraphQL with Java Spring Boot. I hope it was really handy for you. I had a lot of fun putting this together. It was really neat to learn how Java Spring Boot glues together GraphQL and makes everything work. And yeah, I hope you enjoyed this tutorial as well. Give this video a like, subscribe to the channel for more like this. Leave a comment down below if you ran into any issue. Whatever kind of comment you have, it would be great to hear. I hope you have yourself a good day wherever you are, and we'll see you in the next one, everyone. Peace.